Today I have to create a new Ubuntu virtual machine, so it should be an easy task. Let's start by opening VirtualBox. We have to assign a name to the virtual machine. Then we need to select the disk image, which contains the operating system. Next step is to assign the resources to the virtual machine. Default values are fine for us. So let's move forward. Okay, now we can start the virtual machine. In order to complete the installation of the operating system, obviously we have to select the try or install Ubuntu option. On this screen, select install Ubuntu, and then let me change the keyboard layout because I'm using an Italian keyboard. Installation type. At this point, let's choose something else because we are experts, we are system administrators, so we want to manually create all the partitions. On this screen, we can create the partitions. So click on new partition table, create new partition table on this device. Yes, continue. Now we need to add the different partitions. So let's start from the first one. So here, type of the partition, primary or logical, but primary should be fine. Location for the new partition, use as, wow, a lot of options here. It's difficult to choose the right one. Mount point, no, let me change. Well, I think it's better if we go back and select the automatic installation. Hold on guys, this is not the correct way to proceed because we are system administrators, so we must know every single option during partitioning. So in today's video we are gonna discuss all the things that you need to know in order to be able to handle the partitions in your system. Let's start. Think of a disk as a physical container for your data. In order to be used, a disk needs at least one partition. A partition is a logical division of our disk. Partitioning a disk can be useful, for instance, to logically separate application data from user data. Remember that in a system you can have multiple partitions. How many? Well, the maximum number of primary partitions depend on the partition table type. What is it? A partition table contains information about the partition, such as the first and last sectors of each partition. The only thing that you need to know for now is that there are two main types of partition table, MBR and GPT. GPT is a newer standard that is replacing MBR. We will discuss partitioning schemes in a dedicated video. Each partition must have a file system which describes how the information is actually stored and retrieved on the disk. There are many file systems with different properties. Let me briefly summarize the main ones. The first file system that we analyze is X2. X2 is suitable for flash drives and USB drives. A file can be up to 2 terabytes in size, and X2 file system can be maximum 32 terabytes in size. There are some negative aspects that you should consider in using X2 The first one is that X2 file systems are likely to become corrupt during power failures and computer crashes when data is being saved to disk. X2 file systems face data fragmentation issues which hinder performance. The newer version of X2 is X3. File size and total file system size remain the same as with X2. X3 allows journaling. Journaling creates a separate area of the file system where all file changes are tracked. The journal can then be used in case of power failure or system crash to restore data. So, during a file system check, X3 is often faster than X2, but not during normal running. The next one is X4. A file can be up to 16 terabyte in size. An X4 file system can be up to 1 exabyte in size, although most Linux distributions recommend a maximum file system size of 100 terabytes. X4 reduces fragmentation issues and increases performance. X4 provides an option to turn off the journaling features. FAT32 and XFAT are Microsoft file systems supported by Linux. They have no journal, which makes them good for portable devices, such as USB devices. A file can be up to 4 gigabytes in FAT32 and 16 exabytes in XFAT. A FAT32 file system can be maximum 8 terabytes in size, and XFAT file system can be maximum 128 petabytes in size. The last file system that we cover in this video is XFS. If you are trying to find something for your service that works with large files, consider XFS as an option. But keep in mind that it doesn't work well with small files. A file can be up to 9 exabytes in XFS. XFS file system can be maximum 18 exabytes in size. Working with partitions means that you have to decide in advance how to organize the disk space. This could be a problem if your needs change over time. For example, a partition might require more space than originally designed. Instead of resizing the partition, that it is not always easy, you can use logical volume management. Also, partitions cannot span multiple disks, but using the logical volume manager, LVM, multiple partitions can be combined, even across disks, to form a single logical volume. So, what does it mean? Basically, you can distribute physical disk space between logical volumes in a much more flexible way. Linux can swap memory pages from RAM to disk as needed, storing them on a separate space usually implemented as a separate partition on a disk, called the swap partition. The size of the swap partition can be calculated according with the following rules. For instance, if you have a system with less than 2 gigabytes of RAM, the recommended swap space is 2 times the amount of RAM. If you allow for hibernation, then you need to allocate 3 times the amount of RAM. If your system has a RAM between 2 gigabytes and 8 gigabytes, then the recommended swap space is equal to the total amount of RAM. If allowing for hibernation, the swap size should be 2 times the amount of RAM. If your system has a total amount of RAM between 8 gigabytes and 64 gigabytes, you have to assign at least 4 gigabytes to the swap partition. If allowing for hibernation, the swap space should be 1.5 times the amount of RAM. If your system has more than 64 gigabytes, the recommended swap space is at least 4 gigabytes. And then, if allowing for hibernation, in this case, hibernation is not recommended. Before a file system can be accessed on Linux, it needs to be mounted. This means attaching the file system to a specific point in your system's directory tree, called a mount point. A mount point is a directory where an external partition, storage device, or file system can become accessible to the user or application requiring it. A very useful command you should run is findmnt, which will list all mounted file systems. On Linux, it's a good practice to keep some directories on separate partitions. The first partition that I usually create is the boot partition. It contains files used by the bootloader to load the operating system. However, a separate boot partition is not strictly necessary, but is highly recommended to ensure the system boot even if the root system crashes. A good size is around 500 megabytes. I would like to discuss the boot process in a dedicated video. The next partition is the home partition. Its main purpose is to contain each user's personal folder. The size of this partition can be calculated considering the total number of users and how it will be used. For example, web browsing requires less disk space than video editing. Another directory you should assign to a separate partition is var. var directory contains variable data, such as system logs and temporary files. This choice can protect you from processes that could write data until there is no free space left on the file system. There is no rule to determine the size of this partition because it depends on which applications are running on the system. The last partition I usually create is the root partition, which contains the Linux root file system. In order to be able to handle disks, partitions, file systems, there are some commands that can help you. And the most popular commands used to display and manage disks and partitions are df, fdisk, gdisk, and parted. For instance, with df dash capital T, you can display the type of each file system. Fdisk allows you to manipulate the disk partition table. With fdisk-l, you can display all the information related to the disk and partitions. Parted is a program to manipulate disk partition as well. With parted-l, you see all the information related to disk and partition. Gdisk is the abbreviation for GPT fdisk, and it is a text mode menu driven program for creation and manipulation of partition tables. If you want to retrieve the information of a specific disk, you can run gdisk-l and then the device that you want to analyze. Now, let's go back and manually configure the partitions according to what has been said so far.